All right. We will go ahead and get started. A few housekeeping items. For all of you, you are muted during the presentation, but again, please ask questions via chat. And we will answer those throughout the webinar or right when we're done talking. But ideally, we like this to be interactive. And so please do ask those. For those who are concerned or have to hop off at some point, this webinar is recorded. So if you have registered, you will obviously get a recording of this webinar, and then will also be posted on our website after the fact, probably next week or the week after. And you will also receive a link of the webinar when it's finished recording. So I think, with that, I'll go ahead. Let's get everybody to introduce themselves. David, why don't you start, followed by Brian?
Sure. Thank you, James. So David Nachreiner, I'm the Director of Virtual Design and Construction for Hale Technology and Practice. We are a firm based out of Rochester, New York. We specialize in design and construction, technology consulting, BIM services, laser scanning. I've been in the VDC BIM world for about 10 years now. I have a pretty good background in design and construction, an educational background as well. According to my chart here, I'm also in the Army Reserve, so I daylight on the weekends occasionally with the government, which they've also provided me unique opportunities to do construction projects in the Middle East as well, which obviously has its own set of different circumstances. So that's a little bit about me.
Awesome. Yeah. And the reserves too. Wow, that's cool. I'm sure those are great experiences. I met a few people who were National Guard, maybe Jennifer. Yeah, just cool stories.
Too many stories.
Yeah. Hey, Brian, how about yourself, man?
Yeah, Brian Smith, happy to be here. Thanks for bringing me on. Actually, my title is Business Development Manager for owners at Procore. And that actually just is going to change on January 1st. So I'll be Principal Product Manager for GC. So that'll be awesome to be able to kind of continue my drive of GC and experience. I've basically started off as an engineer and gone through all of the pain. And when I first started, it was drafting by hand, and using those machines that smelt like formaldehyde, so to do real blueprints, and really gone through the digitization of engineering and then construction, and just really such a passion of mine to kind of bring together technology and construction and see how we can really innovate the process and improve efficiency. And really, I think it's also just like getting everybody on board and seeing the picture and seeing really beyond that 2D set of plans, beyond the contract, beyond the scope of work that they're actually doing, but how do we pull everybody in and make it a big investment for everyone? So happy to be here. Thank you.
No, thank you both. No, that's awesome. Kind of like you, so I started off in construction in 2006, but grew a pretty large BDC and centralized scheduling and planning department, a few different departments within the last company I was at, and then joined ClearEdge in 2019 to, there was a lot of issues we were seeing, so we're like, let's go try to solve some new problems. You'll be seeing some more of that in 2020 or 2022. Yeah, well, cool, let's get started. So, So we're going to start off kind of with the, again, the flow of this is going from design through pre-con into construction. Many of these problems are fairly pervasive and can not just apply to one type of division of construction, but many different types. And again, this is about awareness. So I think we'll start off with you, David, talking about some of the problems you've seen.
Sure.
1 second.
All right, so this is, there we go. This is an interesting one, and it's come up a couple of times. One on a project that we're currently working on, and one on a project that we came across a couple of years ago. And the issue was floor boxes and where they showed up on the bid documents. We've come across a few instances where floor boxes will be shown on the electrical contract documents, but if there's technology plans, they'll also be shown on those plans. But sometimes the counts don't match, and not all floor boxes are created equally. So some are specifically for the electrical contractor, some are specifically for the technology contractor. So at times there's discrepancies upon who is buying how many floor boxes. In this project example, the low voltage technology contractor was kind of late to the game as far as getting awarded their work, and construction had already begun. Therefore, the slab-on grades were poured, the slab-on decks were poured, but nobody throughout the process thought to think about, well, what about these technology floor boxes that are going to have to be installed once their contract is assigned? So construction went forward without considering them, right? Low voltage contractor shows up and says, hey, did anybody repackage or rescope my floor boxes? And they said no. And then all of a sudden it's a scramble to figure out, well, what floor boxes do we use now, right? We can't use square ones anymore. We have to use round ones. We have to now cut the slab on grade. We have to now core through the slab on deck. So it created a whole kind of confusion of what was actually happening. Specifically, the floor box types actually changed. So our client that we were partnered with came to us and said, what can we do here as far as coordination drawings go to rectify this situation? So we already had pretty well established coordination models of the other trades. We were able to quickly identify locations where they could core through the existing slab on deck to lay out these new floor boxes. This helped expedite locating and kind of reorganizing who owned what as far as that scope went. And we were able to turn around drawings fairly quickly without too much impact upon their schedule. It was interesting. One of the things that I guess I learned from this is that it's, not only from our perspective when we at Hale are bidding on a job to provide coordination services, but for any contractor that's bidding on these packages that may involve other trades or may have some of their scope shown on different bid docs, is just to kind of fully review and digest the information that you're bidding on to make sure that you're not really missing any scope and that nothing's kind of left behind. And in this example, a good lesson learned would have been, the GC, the CM could have said, hey, look, this low voltage sub is falling behind, not falling behind, but they're coming late to the game. We got to quickly repackage some of that work into the other electrician's package so they don't fall behind. So that was something that we found pretty interesting on that project. Yeah,
I think though what I always see is, jobs are moving fast. They're always faster many times, even though when drawings are not vetted or fully completed. So then would you say that then you really have to leverage even more the expertise of, because you almost have to fill in, it seems like, the voids of contract documents with expertise itself. And to me, it sounded like you were asking the right questions, and maybe if they had brought you on earlier or, had people that knew what to ask, some of these, kind of costly mistakes could have been avoided.
I think, in my experience, I think sometimes the coordination team, the BIM team, absorbs the sins of the team prior. And I think that, which is, it's all part of coordination, right? Stuff like this arises, like these issues, and they say, well, this is a coordination issue. Let's let these guys figure it out. And, luckily on both of these projects where we had this come up, we were working with a good team, and everybody kind of reacted and filled their role appropriately. But we adopted the sins of the confusing bid docs at that point, and we reacted accordingly.
Yeah, and this is really tough, right? You're trying then to manage change orders, then it's like there's profit erosion out of the gate. Not ideal. I realized, floor boxes are huge because then there's everything from like your, medical to furniture layout, and these things are so critical. And many times, a big thing I would even say is, if you are doing a layout for cubicles, you want that furniture designer, and you want to really lock in on what kind of floor box or pigtail or power requirements they need then before, like in SDs, schematic design, or DDs, I would think. And the same would go with medical, because many times I feel like they get brought on too late contractually. And it's just kind of this conceptual plan of this is where things are going to go, but then,
It's interesting because it's such a small component, but they play such a kind of big role in the program space of that facility, whether it's medical, educational, correctional facilities, things like that. They really play a role in where they need to be located. So when they're left behind and they have to be added in later as an afterthought, it's tough to get them to where the design team intended them to be.
Right. Yeah. Get people on early is what I'm hearing, and review the
Right.
scope.
Yeah.
Cool.
Yep.
Yeah. That's awesome. Yeah. And again, all of this, at the end, if there's always that question of like, well, we spend all this money on 3D coordination and we're not getting the results. Well, it's like, you got to plan right. You got to scope things out well, or else they're right. So right. I think people who are on the VDC side of the world need to understand the business side as much as possible to make sure that things are happening earlier on, or else you're going to always find yourself in this ROI battle rather than trying to move forward as a company battle,
Right.
Cool. Thanks, David. We got plenty of stories. Okay. So this is a job I was on where we also had a consulting arm at the last company, and so we acted as an owner's rep for a large, very, very large design build project for a large institution. And one of the things where we were doing 5D, analysis and estimating and scheduling. And one of the kind of pervasive problems that happens in a lot of projects that has extreme effects on the VDC side of the world is your schedule. So we see a lot of schedules happen inside of Excel. Like, that's where information goes to die. And two, it's very hard to update. So, the bad part, the great part is it can be easier to consume. Bad part is you may have outdated data and nobody knows about your plan except for you. So on this job, that is what happened in many instances. There were quite a few different things. We always hear that the job can be built in this amount of time, and it's like somebody just magically just came up with that. You have no idea how. And here's an example, right, where data was built in Excel, but really it needed to be in the actual contractual schedule, because when you do 3D coordination, the minute that your model is signed off as being coordinated, then it goes into fabrication. And then after it goes through a kind of a legal submittal approval process that the specs require. Maybe that's a week, maybe that's 2 weeks. Sometimes it could be the same day, depending on the agreements with the owner. And then they've got to go fabricate that. And then after fabrication, then it has to be delivered. And then if it's delivered, it has to be installed. But if you don't have the VDC workflow in the contractual schedule, you're gonna end up stacking your coordination, and it's not going to be very successful. You can try, you might succeed, but it'll be based off luck. And again, like this all, we're in the business of managing risk. So the more risk you manage, the more profit your company makes, and the more likely you are to go home and not hate yourself and the job you're on. So, the impact was that there were definitely delays on the project. And it's then you're stuck with that schedule, and then you're working around that. I think some other things, right, is that just basically even separate from VDC is making sure your logic is correct. And I think for us, we built our own in-house scheduling like analysis tool just so we could understand jobs globally, and it definitely was impactful. And I think it's really critical, even if I know there's tools that can do this, or if you look up things like the 14 points of value of a schedule, you want to look at that, because it won't matter what your scanning or VDC effort is. If this isn't correct, you're going to be in a reactive mode. Some other things when it comes to schedules, and this comes to the guessing, is that it is really good to kind of analyze the historical data of your projects. This is going to be very hard to do if you don't have a database, but you do have a database if you do accounting. So if you have and all contractors do accounting, so you will have an analysis of cash flow, and you will know, like, the amount of work put in place, the pay applications you have kind of defines the length of time it takes to build a job. So if someone says I can build a job, $100 million job in 16 months, but if you look historically in every $100 million job, the cash flow lines up to like 20 months, it's not going to happen no matter what somebody says. But they can try, but unless they're 3D printing and have a 24-hour crew, it's just not going to happen. But we see this all too often, right? And so like this job, for instance, kind of landed at the top of this, very aggressive curve. So was it doable? Maybe, sure. But the rest of the jobs around here were like precast projects or like a single story plant that, yes, may have been expensive, but it wasn't a complex build. So you want to be informed about how you think about like what kind of building is getting built relative to the contract value, relative to the schedule. And the best way to do that is just, go back to historical data from existing projects and see when they legally started to when you finally did close out and finished the job, or like when at least you got a certificate of occupancy. And then you can bring this kind of information to your client and say, hey, look, like this is where we are. This is too aggressive. Can we renegotiate this deal? Because if we finish late, you finish late, and if you have a development loan, that matters as an owner. Like they need to know that because they can like negotiate a better deal with the bank or a lender. If it's a university, like they're wanting to open up that month because they're going to start billing, students the minute that they're projected to open up this space, right? So it's very critical to know honestly when things are going to be done because there's like these huge downstream effects for your client, and you want to do more work with them. And in this situation, it was like, hey, either reduce scope or increase the duration. Those are like your two options. And they ended up doing that. We ended up adding, I think like 3 months to the project just to help out, which otherwise wouldn't have been able to be done. So key component, do some due diligence and don't be afraid to ask the question. You will get 9 times out of 10, they will appreciate the answer. And if they don't, then you as a business need to think about, is this even worth doing? Right? So, yeah. I guess we can move on. Brian, did you have anything?
It's interesting. I'm sorry, go ahead, Brian.
Oh, I was just gonna say, the schedule aspect I find is just, it seems like it's one of those items that, we kind of go through it estimating, we kind of take a look at it, then the project team takes another look at it. And if it's not completely bought in by not just the project team, but all the stakeholders in the project team, you get this exactly what you see in here in these curves. The expectations of reality are different than the schedule, and that's when we start having issues of people pointing fingers of, well, it's not me, I couldn't get in there, it wasn't ready yet, I didn't have the materials, I didn't, it's just all of those things start to come up, and I think the more data, and this goes back to your first slide, of the more data that the team can leverage to build that history of where they've been, different projects, either good or bad. I mean, it's all going to help to build these kind of scatter plots to really give your teams the indication whether or not they're overextending themselves, overcommitting. But ultimately, I think it's really a proof to say, I'm not just whining, I don't need more time. I'm actually saying, here's the proof of all of the work that we've done. And it just starts with good data, right? And a schedule is good data. And it's really hard to extract that out of Excel.
Exactly. Yeah. Yeah.
I think it's in my opinion, it's really, whoever's leading coordination of the BIM VDC coordination for a project, whether a CM is doing it internally or they're having the HVAC sub do it, or a consultant like me is running it for them. It's really on that person who's leading that charge to develop a coordination schedule and plan where exactly we're going to model and draw and coordinate first based upon that original baseline construction schedule, right? And as a partner of the CM or whoever the client may be, it's really that VDC team member, team lead's responsibility to produce a schedule for coordination efforts that coincides with the construction schedule, to flag interferences or differences or issues that we may have with the construction schedule. Because the one thing that coordination should never do, as far as BIM coordination, is impede the actual physical construction of the building. So it's on that lead's shoulders to go to the CM and say, hey, look, I think we're having some issues here, and collaborate with that partner and work on a schedule that works best for the coordination team, gives them the time that they need, and also gives the CM the time that they need to install and run the job appropriately. So I love the topic of scheduling. I think some of my colleagues listening on this are laughing right now, because I'm always trying to tinker with schedules and plan things out. So I'm a big fan of that topic, James.
No, it's great. Yeah. Well, right on. All right. So I think we got Brian. I know we got David coming up. So
the Penthouse AHUs, housekeeping pads. So this was kind of a fun one. This is a job that we participated in a number of years ago. We provided ductwork coordination drawings, mechanical pipe. I think we did the electrical as well. So we had a big hand in the pot for this project. We also led the coordination of this project. So, really the issue was the size of these air handlers that they installed on top of these new penthouses, or inside of these new penthouses throughout this school, associated with these two fairly larger additions. The original bid docs, again, bid doc clarification, called for housekeeping pads for these units to be installed for them to sit on. However, once construction began and the submittal process started, it was discovered that these air handlers actually came on a skid that alleviated the need for the housekeeping pads, which worked out perfectly because the height of the units themselves were almost too large to fit in the penthouses as they were designed anyway. So an RFI was sent up to say, hey, can we eliminate these housekeeping pads? Here's the submittal data, here's how the model looks, and here's how they will fit. Design team came back and said, absolutely, makes sense. And the project moved forward as scheduled. But now these air handlers were coordinated months and months before they were actually supposed to be physically ordered and set into the penthouse. So for whatever reason, the general contractor poured the housekeeping pads anyways, right? They didn't see the RFI correspondences, even though they were on the email chains, which is a whole nother issue. I think their correspondences got lost in translation a little bit. And they poured all these housekeeping pads anyways for these fairly large units. If we kind of go on to the impact of this, or what this kind of created for the project was, at the time they were getting ready to set these units, they were trying to get them set before winter started, right? And then enclose these penthouses accordingly. So crane shows up to the site, air handlers are staged, and now they're getting ready to pick them, right? So they go to pick them, and then they go to place them in, and they realize all of a sudden there's these 6-inch housekeeping pads, and that would put the units 3 inches up into the steel that was already set. So it caused an issue, right? It caused a delay in it caused an issue with the crane, because they had to keep the crane rental longer. The GC had to go in and now chip out and take out all of the housekeeping pads that they installed. And the enclosure of the penthouses was delayed now, and all of a sudden snow is flying, and they're setting these units in the snow before they could get them enclosed. So really it was, we had already coordinated this issue, right? We already resolved this issue, but then it came back up anyways later on, which was a kind of an issue. So what we did as far as our solution goes was that, all we could really do was confirm that, hey, these units are supposed to be without the housekeeping pads, and we recommunicated that back to the general contractor through our historical project data. We sent the meeting minutes, sent the submittal data, sent the official RFI response from the design team removing them. And then basically that's what the solution was. The GC had to remove all of those housekeeping pads. Some of the things that we gathered from here, and I think I'll skip right to my last bullet, is that we really need all contractors to participate in the BIM coordination process, even if they're not physically modeling anything, right? It shouldn't just be on the MEP, FP contractors or the utility contractors to hash this out, right? You have to have the steel guy there. You have to have the GC there, because, when we're coordinating projects, we're having a huge impact on the what's happening on the day-to-day of the project and what's happening, 3, 30, 60, 90 days out. And, people need to be aware of what's going on with those trades, just like this. If the GC was on these calls, they would be aware more intuitively of what was happening with these pads. Another good one from this lesson learned is, we just need better organization of our information as far as how we manage projects. Every single project is managed differently by the GC, the CM, whoever's leading the charge or holding the contracts, or being the owner's rep, right? And we really need to, focus on streamlining, using platforms like Brian's over at Procore, and making the information on the project available to everybody and disseminating it to everybody. And I think things like this would get caught quicker.
Yeah.
Sorry, I had a little echo, guys.
No, you're good. I agree. And I think, yeah, like things like Procore, just the ability to, that's what we used at my last firm too. I think that knowing data in real time and being able to make informed decisions when it matters, and then being able to flag and tell people, hey, check this thing out is a big deal. And if you can, I would, if you can just even get the superintendent from a general contractor to sit in on the call and do nothing else but listen, that can go a long way. Yeah, cool. And I think let's see, we got still up. Ceiling exposed during demo. I've experienced this.
The mystery ceiling. So this was another job. It happened to be a school job again. There's a lot of school jobs happening in New York State over the past number of years. This one was kind of interesting, and it was kind of fun to solve. It created a huge headache for the CM, and like all CMs, he was rearing to go just to kind of get this issue resolved. Existing conditions were drawings were shown, or bid documents were cut. And on the demo plans, they called for the demolition of all these existing ceilings in this part of the school to be renovated. But what they didn't account for is the existing ceiling above the existing ceiling that was attached to the structure above. So we start coordinating, right? And we're coordinating way before demolition occurs. And we're signing off these areas, ducts getting cut for fabrication, pipe is getting installed, hangers are going up, things like that. And all of a sudden the demolition of these corridors begins. And as they start demoing the corridors, they expose this existing ceiling system. And it was throughout about 90% of the space that we were working in. And the issue that it caused is that now all of the MEPs that we had in certain areas in these corridors were now either in conflict with this existing ceiling, or because we had routed some up and through the interstitial spaces of the joist spacing, we're now above this existing ceiling. So it really kind of put a halt on our coordination efforts, or made us go back from our current areas and go back and have to relook at this area. And in some cases where we had duct and pipe roughing out of mechanical rooms to get into this corridor, we were now hitting some of this existing stuff. So one of the solutions that we came up with fairly quickly was that once the GC had demoed all of the first ceiling you saw, we went through and we laser scanned all of the areas where the ceiling existed. We then took that scan data, brought it into our coordination model, and we flagged only the areas where we had conflicts with this existing ceiling. So we kind of did some selective laser scanning, and then we produced a PDF that the GC took that showed where these existing ceilings needed to be demoed and where they didn't, right? Because at this point, because the ceiling wasn't known, the demolition contractor now had a justifiable change order, right? So in order to help him control his additional fees, he was able to take this PDF and say, well, we don't need to demo everything. We're going to save time and only demo where the coordination and the MEPs need us to demo, right? Let me go back. So like for this example, we were able to then model that existing ceiling in and physically see or visibly see where we had utilities above that ceiling, which caused an issue, or below, right? So this is a good example. You got pipe going through that ceiling. We have pipe above that ceiling. You got some ductwork kind of in that tan ceiling. And we were able to then go and re-coordinate those spaces and or tell the GC, demo the ceiling in this area, but only demo, we only need like 10 square feet of the ceiling removed. You can leave everything else in place, abandoned in place. A lesson learned here, this one may have been a little difficult to figure out. Some of these ceilings were hard lid ceilings when the design team did their walkthrough and their building design analysis. But, it goes back to just existing conditions need to be documented much better during the design phase and accounted for during bidding, right? So this was kind of a big miss, and fortunately the project called for BIM coordination. But if it didn't, the laser scanning option would have never been used and the GC would have easily submitted a change order to demo all of these ceilings, and it would have cost the project extra money. Still costed the project some money, but not as much because we applied the technology to resolve the issue.
Yeah, so it sounds like if you're doing an existing conditions project and you're in design, or if you're currently looking at that, bidding on that, ask if there is a scan, and if not, please scan the job. That's what I'm hearing as well.
Or take a peek above the ceiling where you can to see if he has a partner up there on the structure.
It sounds like I'm smelling some connective tissue. There's planning, there's modeling, and there's definitely scanning involved with this, and then the communication portion. So
yes,
seems to be a common theme. Cool. Thank you, David. Yeah, that's a big thing as well, understanding how buildings go together. I think it's one thing to know how to do scanning and modeling, but your ability to highlight a PDF and kind of give suggestions is a big deal, because that's what people need. Their bandwidth is slow. So
sure.
All right. Yeah. So Brian with Procore.
Yeah, I want to touch real quick on one thing. David was there in his last example, just because it's kind of near and dear to my heart of the value of the VDC team and the ability for coordination, and this is one where really you could demo and try to do as much pre-scanning as possible, but some of those unforeseens just happen, and this is a great use case of imagine the delay it would have taken, right? Not just in additional cost, like you were saying, David, if they hadn't decided to use the design coordination and VDC from the get-go. And I always just like to think when things go smoothly, people don't necessarily go, oh man, I'm so glad we had the VDC team. But on jobs like this, it's like, oh my gosh, not just the money savings, but the time saving, the delay, of all the other trades that would have been impacted, any maybe additional redesign, right? Like those are the things that are unmeasurable that when it comes to VDCs, teams, and actually the design coordination side of it, kind of get, they go unsung until it's really the crunch time and the, so to speak, hits the fan, right?
Yeah, that's right. That's a good point.
What I would say is whenever there are people who are like saying, oh, our company's just not ready to do that, or this job doesn't have the money, or we're just not there right now, it's kind of like, well, ask your executives this question. Like, we're seeing an example like this from David and from Hale TiP, and I think one of those questions is, okay, so unless you want to be in a change order fight the entire project, so unless the job is set up where you can basically change order every problem that happens, and that's how you make money. So if you're hard bidding a job, maybe you can take that tactic. It still destroys relationships, though, by the way. Right. If you want to stay in business, and medium-sized companies are now doing this, right? Like they are, this being 3D coordination. If you really want to stay in business and be sustainable in your region, you're going to have to do this. Right? Because it's not even, it's like, well, how much time do you want to spend negotiating all of these problems? Like, do you have the resources and the time? The job's already going fast. Do you really want to spend 50% of a resource, a PM or whoever, to do contract negotiations when they can just have a fluid job? Or would their time better be spent bidding on another job and building relationships and networking? I would think the latter.
Yeah.
Right? Not trying to fight over this to fight for an additional 0.02% fee. Like, help build that person up to win the next job.
Yeah, you're exactly right. The owner remembers that, and the owner will definitely hire again the team that was actually looking out for the best interest of not just the project, but the actual owner and their resources and funds as well. So it's a great and I think it's one of those things that's going to continually come up even more and more. The ability to scan has gotten democratized, but I see retros just being more elaborate, knowing the envelopes, being able to really understand where we're at with the ESG and compliances and what is the airspace. And now we need to know those kind of things, whereas before it was kind of a nice to have.
Exactly.
Yeah.
Exactly.
All right, TI build out gone wrong. So tenant improvement is for what TI is. And I think this is the problem that we're looking at here is kind of it's just everywhere in construction. And this could be a brand new building, and in this case it was. But it can also be an older building where you know, maybe there's been some work done to it and you have an as-built set of plans, and the architect or designer goes wild and is ready to just build off of this set of plans. They bring it in the CAD, they start to do all their layout, they work with and coordinate with the new tenant that's going to be in there. What do they want the space to look like? How big do they want the kitchen? How many seats are going to be here? And then they start ordering all this stuff. And at that point, back to schedule, you know, the ship has sailed, right? The contractor's been hired, contractor goes out, starts doing the tenant improvements per contract, breaking it back down, like David was saying, into the electrical, into the technology scopes of work. And everything looks great until they start to go and put in the actual desks, the cubicles. And kind of back to the floor, you know, diagram, the floor boxes, it's like this becomes really critical when you're dealing with spaces that, you know, get built out to typically inches, right? We're not talking, you know, millimeters or anything, like we're talking pipe fitting, but the desks and egress become a safety issue. And so you have to meet those minimum specs. Well, in this case, it was a little too late. They found out that it was the building was 2 feet smaller in this one area than was actually in the set of plans. Ultimately, the funny thing is the building was 2 feet smaller. And so after going through and figuring all this out, the impact really became that it was a pretty major delay. The space had already been finished, basically. It was time for the last little bit of installation for the equipment to be installed for the desks. And really they had to, ultimately, they weren't going to rip everything back out. So ultimately, they had to reorder a bunch of different desks. But they also, the unexpected, unfortunate thing was for the new occupant owner, they weren't able to seat as many people as they wanted to. I think nowadays maybe that's not as big of an issue with, you know, so much work from home, but it's that whole expectation of what you think you're getting, what you're paying for, and kind of to rectify it, to really figure out how to reseat all of those cubes and how to replan what that floor space was going to look like. Now they had to redesign the entire floor again with the right set of plans, and maybe not optimized because they were trying to use the same set of furniture that they were able to already buy in the first place without having to return it, because you can't return that kind of stuff, you know. And the lead time on it is pretty long as well. So I believe specifically on this one, they had to come back and install more furniture later after it was delivered, months after people were occupying the space. So again, just additional costs. So lesson learned, check as-builts, right? Verify. This kind of goes back to David's last one. You can't see everything, but man, if you just plan a little bit ahead and know where the big oopses kind of can come up, and this is just a simple TI. So measuring twice, verifying the plans, verifying the contract, verifying the schedule are all of those big areas that really kind of should be examined more than once on every project.
And it seems like, I'm curious, right, that with all the things that are happening right now with supply chain, it almost feels like it matters so much more right now to know, you know, exactly what the as-builts really are, because you just don't have time to even order. There's no second chance. You know, lead times are even longer. I can't imagine, like, you know, traditional ways of thinking about how to do a TI probably are out the window. Like you almost need to have it all locked down.
Yeah, yeah, and it's so modular now too as well. So, you can't mess up a little bit, right? Either panelized construction, desks that are already prefabricated, those kind of things that really, lock you into where you're at. But ultimately, I think it comes back down to labor as well. I mean, just getting a whole nother crew to come back out and install, 6 desks or 8 desks, that's not cheap, and that's a whole nother trip that maybe, like you said, as well, would be better used, to actually be on a project where and they're focused and making money instead of just trying to make
Burning hours.
exactly. So the
Yeah,
cleaning crew.
I
exactly.
think the laser, I mean, again, the laser scanning is a common theme here, but I mean, I think that's important. I mean, there's jobs that at this point I won't even bid on or accept if they don't accept our laser scanning number, right? So we'll look at a renovation job, we'll give them coordination drawing numbers, even if the specs don't call for laser scanning, we're still putting in there a line item for scanning because there's no point in us even coordinating or laying things out if we don't scan. Otherwise, we're just really regurgitating the original design information, which is not
Yeah.
the intent of coordination. So it's a good point.
Exactly.
Did everybody hear that? It's true. And we were in the same boat. We did not even accept, if we couldn't scan the job, we weren't doing it. Because it's just too, I mean, again, we're managing risk, and it's also like, it's yeah.
But at the end of the day, it benefits the owner, not just the occupant,
Totally.
right? That's
Yeah.
Right.
how much leasable space do I actually have here?
Exactly. And I think that's the thing, the goal, it seems like for the common themes are, it's scanning is a catalyst, but so is modeling. But what we're really trying to do is explain the value to the owner. And I think the goal, and I'm hearing throughout this common theme, is just finding ways to explain this upfront when you're negotiating a contract, either with a GC or with the client themselves, because it's not enough to hope that your company is going to be doing, amazing workflows that are beneficial through altruism. You really need to understand the value it brings to the client if you want it to happen. Yeah. So it looks like this is
All right.
about column lines not being correct. I've seen
Column
that.
lines are off. This is a project that's almost finished. This was the first phase of it. So this is a bus garage project. They had an existing bus garage, but now they were building a new addition off of that. So they had existing column lines, which you can kind of see in those red frames in the bottom right corner, and then they had to, extend those out to create this new addition, and they were going to share column lines. So we started doing the MEP coordination drawings and kind of overseeing and facilitating the actual coordination of this project. And it just so happened that one day I was out there when they were digging foundations and pouring some foundations and chatting with the GC's foreman and catching up with them. And he just so happened to say, "Hey, Dave, did you hear that the column lines are off by about 4 inches, plus or minus, in various spots between these 4 frames," right? And I said, "No, I didn't hear about it." At this point, we were getting ready to submit coordination drawings for this existing space going into the new addition. So I took a couple of measurements, and we had our foreman take a couple of measurements for the clients that we were working with. I went back to my office. I measured in Revit and in CAD the grid lines that the design team showed versus our measurements, and they were off. So instead of being 20 feet on center, one was 20'4", one was 20'1", one was 20'5", right? So they were at varying levels. However, it never got communicated from the GC and the CM back to the MEP primes that there was a discrepancy. So now at this point, all of our drawings are being dimensioned off column lines that were off, right? And they weren't going to line up from the existing into the new condition. And also the steel model, the structural shop model, was built upon these grid lines, but the GC was moving forward with the foundations based upon the design document. So we quickly realized, let's get the scanner out there and resolve this. And so we took a number of strategic laser scans to see where the existing frames were or column lines were versus the where they had already started pouring foundations. And this allowed us to give the scan data to the structural contractor. They were able to then move their model and their column lines accordingly to where they were actually physically being installed. And that also allowed us to update our grid line so that our dimensions that we were giving weren't, 10'4" to column line 1. They were actually 10'4" to column line 1 instead of 10'8" in the field, which would have created a domino effect on the other trades. going downstream. So again, same lesson learned as before. Existing conditions need to be documented much better during the design phase and accounted for during bidding. These grid lines were exposed during the design process. So a simple measurement to create their design drawings, their proposed design drawings, would have shaked this issue out way before construction even began.
Yeah, and I know we got we're a little bit pressed for time, but I'll say that one thing that we had to do is, I think any job, we were a $1 billion firm, but I think that any job over 15 million, we got burned on a few projects to a point where any job over, it was 15 million at the time, I don't know what it is now, but we would do a model on it. So we consult out, and unless we could do it internally, and audit the model compared to the drawings before we
even
ever.
A low fidelity model is so helpful, right? To just even pick these things up
yes.
A couple inches is not a good thing to find out when you're erecting steel or trying to marry something into an existing, as David was doing.
Yeah, so if you all are trying to figure out on the call ways to mitigate risk, hire someone to, unless you have the bandwidth internally, hire someone to do a quick low fidelity model like Brian was mentioning, because knowing this, you can negotiate this back into the contract, or at least make them aware of it so it's getting fixed before you're bidding on certain things. You'll save everybody a lot of money and time. Okay.
All right, James, I'll go through this one fairly quick because I know, like you said, we're pressed for time. So this is just something that Hale comes across quite often. It's unclear Division 1 coordination specs, right? We've been on a lot of VDC work, and we're involved in a lot of design and construction projects where we are digesting the information shown to us in Division 1, right? To get an understanding of who is responsible for running coordination. And what we found is that these Division 1 specs either don't clarify who is responsible for coordination, they lack detail of what the fruits of coordination are to be. They don't require requirements or credentials from the CM or the subcontractors participating in coordination. And they oftentimes contradict each other. If you can go a couple more slides to the right, they lack design team model sharing, they lack detail, they lack, a coordination lead being identified and qualifications for those contractors. We often find that sometimes the Division 1 specs call for the CM to manage coordination, but way down at Division 23 of the same project, they say the mechanical contractor is to run coordination. So now both contractors are carrying fee for coordination management, and now the fee for the project is rising, and the contractors are no longer working in a linear path because they're reading contradicting information from the same project. And so there's confusion before the job theoretically even begins. And some of the impact is coordination drawings are not produced. They're only produced by some contractors, or worse, they're not submitted at all, right? So lessons learned: we need better Division 1 specifications. We need to identify who the lead is, what their responsibilities are, and how they are to work and manage the coordination of a project. We give presentations to different CSI chapters and ASME chapters on this, and these are a few screenshots from those presentations to try to get design firms thinking of how to build a better Division 1 spec so that their design can be coordinated the way it's intended to be built.
Awesome. Yeah, and I think I see down here coordination sign off. You can negotiate that the minute that you've signed off. You can go into fabrication because you're effectively signed off on the model itself. So those are ways to speed up time on the schedule.
Right. So just this last one, it's kind of our recommendations of what does a good coordination spec look like in Division 1, right? They have their own spec section number within Division 1. They call for the requirement of an execution plan, and they also have a narrative of what the fruits of that process will look like and what their impact will be on the project itself. Yeah.
So yeah, read the spec. Just quickly dive into that spec. Have someone on your team do it if you've got the time. Like, it's a big deal. Because again, it's even though the model is the thing that we build from, contractually, the contract documents are the 2D drawings and the specs. So they still are a very high priority. One day it'll be different. One day we'll just use the fidelity of the model. But one day. Okay. So Brian. Oh, muted.
There we go.
Yep.
Sorry about that. Indigestion from a digester. If anybody knows what a digester is, maybe they've been on a wastewater treatment plant before, or if you haven't, it's the big kind of it's like look like a giant chemistry set essentially, where the stuff goes to become inert and separated, is really how it all works. In this case, the engineer had designed a pretty complicated concrete structure. You can see from the picture there, it's about 85 feet high, and not really sure why, but they designed it with this kind of a 40 to 45 degree cant to make it kind of like a cone, right? And on top of that was a steel lid that would be installed. We've been laser scanning everything pretty much the entire project. Again, James, back to like looking at the areas that we know there's problems. Anytime that you're connecting to something existing, probably should scan it. And so we scanned the existing before, we scanned it during, and then this time we had actually scanned the forms before we had poured, just to verify that not just when we're surveying it, that it was actually before we poured where we wanted it to be, but also just underneath it to make sure everything wasn't going south. So as they poured, though, apparently the forms deflected, and you can't see, a 3-inch deflection at that angle 85 feet up until it's hardened gray. So once concrete's hardened gray, there's it did. And so it was one of those opportunities, and again, we caught it before we did the initial lift of putting the prefabricated steel up there, because after it was poured, we were going around just doing checks, again, using a robotic total station. And at that point, we realized that there was something off. And this is kind of a neat story too, of like, you can use robotic total stations, laser scanning, and BIM all together. It is the best mode to solidify all of your workflows, especially if you have a team in the field that's able to go and do layout, and actually be able to pull back into your model where those real world points are, kind of like all of our other kind of discussions of what's the reality versus what was designed. And in this case, we had enough information from the laser scan and the robotic total station to be able to understand where the deflection happened more than the other areas. And then ultimately, we also laser scanned the lid, because we're like, well, geez, what if the what if the lid isn't exactly perfect, right? That would be really bad. And these were all kind of like thoughts as we were going through, and we called this a critical pick as well. So it was over 15,000 pounds. It was one of those things that is kind of irreplaceable. It would set the contract back into LDs. So we didn't want to get into any of that either. So we made sure that the crane's pad was good, the crane could lift it safely. All of that was done using laser scanning. And then we were able to also verify the areas with the total station after we had identified the areas that needed to be removed, and got the engineer's permission to clear off some of the about 1.5 inches on each side of the digester lid area to be able to set the lid in securely with the tolerances that were specified. So because of the model and because of the accurate information, how fast we're able to turn it around, we're also able to get an RFI from the engineer saying, yeah, it's supposed to be 18 inches wide, but we're going to make it 15 inches wide in this one area at the maximum. That would be our most reduced, and then we're going to taper it back in. And we got our RFI approval, and they changed it, and we were able to actually even go back to the form company that had done the form engineering for us, and they contributed a little bit of money as well to solve for the fix and the delay, because we were able to prove that we had set the forms correctly to their specification, and the deflection shouldn't have happened to the level that it did. So kind of a cool case story. So lessons learned really is like, it doesn't hurt to pre-plan. Even when you pre-plan, stuff happens. And then when stuff happens, having back to David's case, having that information in the background, knowing where you're at and how to quickly move forward, it makes it a pain and more of a learning lesson to move forward, where everybody just wants to get it done, is excited that we know what we're building, not this kind of, it's not my problem, it's his, or it's the engineers, and everybody just kind of looks at each other. So a good example of when things go bad, having information is critical.
Yeah, and I think, again, it's modeling, scanning, being on control with layout. Like we may go over a little bit, and we'll just bleed this out for another 10 minutes, I think, and then we can call it, because there's some good stuff. Because I think what's really important is, right, you can scan all day, but you want to make sure your scan data is on a control network, because that's what the model design is based off of. So if you try to manually align, if you do cloud to cloud and you manually align to a model, you're causing yourself potentially a ton of problems. Because what about if the building was built wrong? You're aligning to a column that's now 2 inches off. You don't want to do that. Right. So like you said, using total stations, robotic total stations, and kind of combining scanning and that together are very critical. And then obviously this is awesome, being able to kind of think about the crane picks, where laydown area can be, is very important.
Yeah, and I think it was a combo of all sorts of data from, we had UAVs, we had terrestrial scanners, and then total station data, so putting all of those together, like you said, really helped present that good opportunity to leverage everything. And then ultimately the owner wanted the model when we were done.
Yeah. Yep.
I think modeling, like your image shows there, modeling for site logistics is a wildly underused tool in the pre-construction planning process for that GCs and CMs underutilize. I love that image that you have there.
Yeah. 4D scheduling too.
Yep.
Until you build it out with a schedule, you add elements to it, you will find so many issues. So yeah. Okay, so I think one thing we've realized, right, is that we've got, again, this kind of connective tissue between planning, scanning, and modeling, but then there's this human element that people still install things wrong. So how do you make sure there's some form of accountability? And one thing that we found was you can see the scans in the background, and we see these issues. And then the question really comes, well, okay, how do you keep these issues from occurring? Because if this pipe is in the wrong, or this column's in the wrong spot, and it's inside of a wall, well, now that wall's got to move. This steel post is not moving, most likely, right? So it really does matter that you put all this effort into coordination, that you actually are validating and ensuring that things are getting installed correctly. So our solution was to scan on site and do a pre-pour scan, and we negotiated an additional day to scan and do a QA of the pour before the following day. That's very rare. So unless you have an open-minded client, that can be very hard to do. And so we still have this pain currently right now of time, where people want to do pre-pour scanning, but it's still like an 8-hour workflow. Maybe something will change that. But yeah, finding issues. We were out there getting on control, right? So we'd have to shoot in control, get on control with a scanner, and then send that out to the VDC department to then analyze that against the model. The more of that can happen in near real time, the better off everybody is. But what we did end up finding, right, is we found lots of issues, and it led to us being very proactive. So in the exact same building prior, there were like over 600 installation errors, right? This time around, we had 36. So while we did have to negotiate an additional day, we went from it was a mixture of being able to scan prior and finding those issues. You can see we had like 10 deficiencies on the slab on grade, and then it just instantly dropped down, and that's because people were being held accountable. All trades, including ourselves, right, as a GC, but also MEP, structural, and this really does. The job finished 2 weeks ahead of schedule, made way more profit, and just decent amount of more profit, actually. And I think the only ideal thing we would have done is we would have used some automated tools to kind of highlight the issues rather than doing a lot of this manually. For us, it was Verity. It's one of the reasons I'm here. And I think that, these things really, the ability to establish accountability in this whole process really does help kind of complete the cycle of getting a building built correctly and on time and on budget. So, yeah.
I'll make this one pretty quick here. This was just again I think the problem was the engineer designed and specified specific generators and fans to go in for this retrofit. It was replacing some existing generators that were in there that were going to be undersized. And sometimes, I think knowing all of, again, the as-built information is really important. And the owner this time actually decided and knew before bid that scanning was important. So it was great to be able to have pre-bid all of that scan information. And because of that, it allowed us to kind of think outside of the box because we had all of the tools to be able to take things apart and put things back together. So we were actually able to work with the equipment manufacturer pre-bid to verify that we could actually disassemble these things that came in on skids. So these are really, really large generators that would typically be on the back of a semi. And the generators that were in there the building had been built around the generators. So the original plan that the owner had come up with was, hey, general contractors, figure out how you want to get these out and how you want to get the new ones in, but you only have 72 hours to do that downtime. You can do all the I think it was actually 48 hours that you could go without it. And so you could do all the pre-work, and they expected demo to happen and a bunch of holes to be dug and pits to be made and shoring. And eventually what we were able to do is, because we had all of this information, we could work with the structural engineer and verify that, hey, we actually didn't need to cut any openings. We needed to remove a few doors. But we were able to take these apart in small enough pieces and had the actual equipment manufacturer send us all of the modeled pieces that we could then float through the space as if we're walking them through on the actual trolleys that were designed to be able to push these around. And then, of course, we put in crane hoists to be able to reassemble them once they were back in place inside. But because of that, we were able to actually get the job. There was nobody that bid on this job to start off with. And then B, that reducing that risk, that level of risk, James, that you're talking about, we knew with certainty that we're able to do this and do it correctly, and with all of the warranties and everything else that goes with installing and commissioning a piece of equipment.
I think this is a perfect example of that. You always hear, this isn't a BIM job or this isn't a VDC job. We don't need to use that on this job. This is a perfect example of a small job that, no one would ever think to use these workflows on, but here it is, saving thousands and thousands of dollars of excavation, cutting a hole in the foundation to get inside these things in. It's such a simple tool. It was the right tool for the right job, and it kind of gets rid of that myth of there's no such thing as a non-BIM job. So I like this one a lot.
Yeah. that's a prime example. Yeah, I always say here, and well, it's just not the right time for us. And it's like, you can make it the right time. It's kind of like, and the amount of, it does two things, right? It bolsters your career, but it bolsters the company's, brand. And also just, yeah, the ability to win the job, have it go smoothly. And sometimes I'm wondering, like, why would you not do these things? This is awesome, Brian.
Super fun.
Yeah. So, I mean, these are great kind of diverse amount of examples. I think really kind of showed the different aspects of the building itself. So I really appreciate everyone. I don't think there's any lasting comments, David, from you or Brian.
No, this is great though. I appreciate the conversation, and thanks again for having us. And any way we can kind of continue the adoption of scanning and modeling and VDC and design and all those things combined, really, I love being a participant.
Yeah, and we're going to keep going with some of these. I think really kind of talking about the issues themselves into next year. So for all those, be aware, we're going to really kind of talk about solutions to problems. It's and how this can be solved. Sometimes it deals with tech. Sometimes it's just knowing how to ask the right question. So David and Brian, really appreciate you being a huge part of that. Yeah, and everybody have a great rest of your year in 2021, and so for a great 2022. So if you have any questions,
thank you, James and Clearage, very much for having us. For sure, this was wonderful.
Yeah, and for the others, reach out to Dave, to David and Brian. They're experts. They know what they're doing. So, and know a lot of people, and they themselves solve a lot of problems. So, and you can always reach out to us here at ClearEdge. So, all right.
Cheers, everybody.
Cheers, everybody.
Thanks, guys. Good talking with you.
Yeah, likewise. Bye.